Applications of matrices. We need to learn to solve a matrix equation. So you have your notes here, and when you read that, when we convert our system of equations, you've got your coefficient matrix here, you've got your variable matrix, and then you have your constant matrix. So the way this works, the way we solve a matrix equation, we need to find the A matrix's the A matrix's inverse, which is right here. We did that in the previous video. What you notice is that we multiply the A inverse to the left of both sides. Remember I said order matters. Then we have the commutative property, the associative property, where we can regroup these and multiply the A inverse times A matrix. But we already know that that gives us the identity matrix, and we also know that the identity matrix times the X matrix is going to leave us the X matrix. So that all we have to do in order to solve a system of equations using a matrix equation is find the inverse of the coefficient matrix, multiply it to the B matrix, and then you will have the matrix that has the values for your X and your Y. So let's get started. Okay. So the way we find an inverse, remember, is we take the A matrix, we extend it, we augment it with the identity, and then we do row operations to turn the left side into the identity, and the right side of that augment bar will be the inverse. So we want to start, what I did was I went ahead and did a row swap. Okay, just like that. So then I'm going to force the 2 to become 0. So I'm going to multiply row 1 by -2 and add it to row 2. 1, 5 doesn't change. -2 times 2 is 0. This is -2 times, or -2 times 1. -2 times 5 is -10. And -3 is -13. 2 times 0 is 0, plus 1 is 1. -2 times 1 is -2, plus 0 is -2. Okay, so now we need to divide both sides by -113, or the row 2. Excuse me, I'm thinking algebra. So 0 times -113 is 0. -113 times -13 is 1. 1 times -113 is -113. And then here we're going to have 2/13. Alrighty, now I need to multiply the second row by -5 and add it to the first. I'm making sure my video's on the paper. Okay, so this doesn't change. So I have -5 times 0 is 0, plus 1 is 1. -5 times 1 is -5, plus 5 is 0. This is going to be 5/13 plus 0 is 5/13. And this is going to be -10/13 plus 1. So let me just remind you of how you get that done. That's -10/13 plus 1 is -10/13 plus 13/13, which is -10 plus 13, which is 3/13. So that means that your inverse, A inverse, is 5/13, 3/13, -1/13, and 2/13. And yes, sometimes those inverses are fractional, and you just have to roll with it. So what I know then is that the matrix XY, the general matrix, column matrix XY, is going to equal A inverse times the B matrix. So we're going to leave the left side alone. We're going to insert our A matrix. Okay, and then my column matrix is 4, 2. And notice the dimensions. This is a 2 by 2. This is a 2 by 1. So we are definitely able to do that multiplication. Okay, it looks terrible, but it's not going to be that bad, because what we're going to have is 5/13 times 4 is 20/13 plus 3/13 times 2 is 6/13. And then we'll have negative 1/13 times 4 is negative 4/13 plus 2/13 times 2 is 4/13. So finishing that out, we've got 26/13 and then 0/13, so that our XY matrix is going to be 2, 0. So your answer looks like this in column form. It also means that your X value is 2, your Y value is 0. If you think about the idea of an ordered pair, because really we're just looking for the intersection of two lines, just to make some connections here, you've got the ordered pair 2, 0. So that's how you multiply a matrix. Okay, I want you to look at this next one. Okay, this one has a little bit of a different feel because it has a 2 by 2 and a 2 by 2. Get my scratch paper here. So let's get started with that. So what we know, remember, is that A times X equals B, so that if we find the inverse of A, multiply it by A, this is literally what's going on. And it goes like this every time. So this is the X matrix. So what I'm going to do every time is I'm going to find the inverse of this matrix, and then I'm going to take the inverse of that matrix, multiply to this matrix, and I'll have my X values. So yes, there's some tediousness to it. It's just in the nature of the beast. I think you can see why it lends itself very well to a calculator or a computer. In fact, this should be an augment bar. Okay, so now let's multiply row 1 by a third. This is going to be 1, 1/3, 1/3, 0. This is going to be unchanging as far as row 2. Okay, so then I'll take row 1, multiply it by negative 4, add to row 2. Row 1 does not change. This is negative 4, and 4 is 0. So I've got negative 4/3 and 2 will give me 2/3. Go do the math on that, it does work. Negative 4 times a third plus 0 is negative 4/3. And then negative 4 times 0 is 0 plus 1 is 1. Now we need to make the 2/3 1, so we multiply by the reciprocal. By now you should have noticed that the way we do these row operations, it's the same process. When you're zeroing out an element, you multiply by its additive inverse to the equation that has the 1. If you're trying to make a element 1, you're going to multiply by its reciprocal, and that always is true. This is 3. Okay. 0 times 3 halves is 0. 3 halves times 2/3 is 1. 3 halves times -4. The 3's cancel. The 2 divides to -4, so that'll make a -2. And then 3 halves plus 0 is 3 halves. And we're almost finished. So now I need to zero out the 1/3 here. So I'm going to multiply by the additive inverse of 1/3, which is -1/3. Second row doesn't change. This is 0 and 1 is 1. This is -3 and 1/3, or excuse me, -1/3 and 1/3 is 0. This is -2/3, okay? -2/3 and 1/3 is, hang on a minute, what have I got going here? I've got -2/3 plus, actually that's positive, okay? See that? Positive plus 1/3, that's 3/3, which is 1. Be really careful, it's easy to make mistakes. All right, here, the 3's are going to divide out, so I'll have -1/2 plus 0 is -1/2. So my A inverse is 1, -2, -1/2, 3 halves. So now we'll go back up. There's our X matrix written in general. So I'm going to go now grab the inverse of A. So the only time you have to do row operations is to find the inverse over here. Now we're going to go pick up matrix B. This one happens to be 2 by 2 as well. They're both 2 by 2s, so we're allowed to do the multiplication, or it is possible, I should say. So what we're going to have here is 1 times 3. We've got 3 plus -5 halves, and then we've got 4 plus -2. That is wrong. Let me start over. We did this one to this one, and we did this one off. This is going to be -3. Okay, and then we'll move down, and we'll have -6 and 8 halves, which is 4. So that's plus 4. That's not 8. That's 15 halves. Excuse me. All right, and then this, see how easy it is to make errors? And then that is 18 halves, which that is 9. For sure, I know that. Okay, so let's get back down here. And then we add 3 to -5 halves. That's just 6 halves minus 5 halves is 1/2. I'll just do that here, and then I'll clean it up. This is going to add to 1. This is going to add to 1. And this is -12 halves plus 15 halves is 3 halves. So my solution matrix is that. Okay, so technically we've got an X sub 1 and an X sub 2 and a Y sub 1 and a Y sub 2. So that's how you find the solution matrix for a 2 by 2.